All right, in this video, we're going to be looking at some different ways to integrate with ln. In the previous part of this chapter, we just looked at pretty simple integration. We combined power rule and the ln rule. What's going to happen is you're going to see more examples that have a little bit more going on. So we're going to have to talk about breaking up fractions and other integration processes. Our first example, so example 1 is x squared plus x plus 1 divided by x squared plus 1. So you really need to make a note here because if you have, so we can't integrate this. U substitution does not work because if we do a u of x squared plus 1, du is 2x, which is not what's on the top. So u substitution doesn't work. If you have the same degrees, or, and when we talk about degrees, we're talking about our exponents. So the highest exponent tells you the degree. Or you have a smaller degree on the bottom, then what you're going to have to do is you have to divide the polynomials. So this is really important, and we're going to be talking about how to divide them. So this is something that goes all the way back to Algebra 2, but we may not remember exactly. If you're going to divide, then what is on top goes inside of your quotient. So we have x squared plus x plus 1. And we divide that by what's on the bottom. So that is going to be divided by x squared plus 1. Now, your division process is the same as if you were going to do long division with numbers. So the first thing that you're going to do is you're going to say, how many times does 3 go into 7? Well, how many times would you multiply x squared by to get x squared? Well, it's just 1. At first, you're only looking at this first term. Polynomial division is a little bit different. You kind of ignore this 1 on the back until your next step. What you do is you multiply this 1 to both terms here, and you write it under. So you have 1 times x squared, which is x squared. 1 times 1 is a 1. So I'm going to put that under my like term. I have a 1, so I'm going to put that under there. I'm not going to put it under the x. Now remember, if you're going to do this, your next step is to subtract. So you're going to subtract x squared. Those are going to cancel. Also subtracting 1. Those will cancel. So the only thing that you have left is dropping down this x. Whenever you get to the end of your division, that's your remainder. So this is our remainder. So we have plus a remainder of x, and we write it over what we originally divided by. So this is our new integration. So we take that and we write that down here. And our integration has changed from x squared plus x plus 1 over x squared plus 1 to the integral of 1 plus x over x squared plus 1 dx. Now this, we can use some rules for. The 1 is going to be a power rule. So I'm actually going to split this up where I'm going to use different rules. So I'm going to integrate 1 dx. Plus, I'm going to be integrating x over x squared plus 1 dx. Now remember, to integrate, to result in an ln, you have to be integrating u prime over u. Well, in this second one, if we have u as x squared on the bottom, u prime would be 2x, which means we need a 2, which means we have to put a 1/2 out front. You do not need to show the u substitution. You can if you want. It's a u equals x squared plus 1. So du is 2x. You don't necessarily have to show this. You can just put the 2 in because we know we need that as the derivative of our denominator. But if it helps to show it, then you can. So now we can integrate this. When you integrate 1, it's just x. Come on. Plus, integrate, we have 1/2. U prime over U gives you the ln of the absolute value of U plus C. So this will be the ln of the absolute value of what's on the bottom, x squared plus 1. This is indefinite, so you need a plus C. And that's our answer. So once we get to the integrating, we can kind of split that up and do that process. The biggest change here is this division. I know you hate it. I mean, I can't really do anything about it. It'll be on the AP exam. It's something that you need to know how to do. It's just kind of how it is. Also, more dividing. So let's look at another example of this. So if we are dividing here, we would have x to the 4th. Now this is plus x. See how there's places missing? Like a lot of our polynomials will count down. X to the 4th, x cubed, x squared, x, and then the number. If we have places missing, it really is nice to put placeholders in for that. So we have a 0 x cubed plus a 0 x squared. And then we have an x term, it's just plus x and minus 4 are already in the problem. So x to the 4th, x, and -4 are there. I just put in zeros for things that I was missing because it helps us kind of keep everything straight when we're dividing. We are dividing x squared plus 2. So again, x squared, so x to the 4th divided by x squared. That'll go in x squared times x squared times x squared is x to the 4th. X squared times 2, I'm going to put that under my x squared term, is 2x squared. And then remember, when we divide, we subtract everything. So both of those are subtracting. X to the 4th minus x to the 4th cancels. We're not going to drop down that 0 because it's just a 0. 0 minus 2 is -2x squared. And then we drop down what we need. Usually we only drop down one term at a time, but if we don't use it, then we can drop down multiple terms at a time. It really doesn't change much about the problem. You just might have to drop them down again. And then we have, we're looking at x squared into -2x squared. So that would be -2. And then -2, we multiply -2. That'll be -2x squared. -2 times +2 is -4. Subtracting two negatives would make adding, and both of those cancel. We'd have plus x as our remainder. When we have a remainder, it's plus, so it'll be plus x over what we originally divided by, x squared plus 2. This is our new integral. So now we are integrating x squared minus 2 plus x over x squared plus 2 dx. I'm going to split this up where I see I am going to have different rules going on. So I'm going to have the integral of x squared minus 2 dx plus a different integral with this fraction. Remember fractions, if we can have the derivative on the top, it's an ln. So the derivative, so if we used a u substitution of x squared plus 2, then du would be 2x dx. So that means we need a 2, which means we have to put a 1/2. Sorry, it doesn't want to write a 2. I don't know why. There we go. So when we integrate this, integrating x squared is the power rule, x cubed over 3. Just a number will be 2x plus 1/2. This will be ln of what's on the bottom. Oh, absolute value. And then plus c. In this case, we don't necessarily need an absolute value because x squared will always be positive. Adding will still be positive. So you could have put parentheses there just because they aren't necessarily needed, but having them there isn't wrong. So That's our answer for that one. Let me make sure I put absolute. I did put absolute value up there. Also, these could have gone because x squared plus 1 will always be positive. So if you just wanted to put parentheses there, that'd be fine because the absolute value isn't going to change anything if it's already positive. Now we are going to look at a couple more ways to integrate some indefinite integrals. Our third example is the integral of 2x over x plus 1 squared dx. So in this case, we're going to need to look at u substitution. And this is going to be an example where we have extra x's. So we're going to have to remember this process. We've done this process before. So when we do that, our u substitution is usually our inner function. So let's go ahead and say that u is equal to x plus 1. If that doesn't work out, we can always scratch that and restart with a different u. That means du is 1 dx. Well, this 2 I can move out front and worry about later. I have the integral of 2x over u squared, and du is just dx. But I can't mix these. So I'm having a problem here. So whenever I have this problem, I go to my u equation and I solve for x. So x is u minus 1. So I'm going to put that in. 2 times the integral of u minus 1 over u squared du. Now in the last two problems, when we look at the denominator, it's a group of things. X squared plus 1, x squared plus 2. In this problem, once we simplify this with u substitution, we have one term on the bottom, u squared. When we see this, I'm going to cover up that other one. We're not there yet. That means that we can also say that this is 2 times the integral of, and divide each of those terms. So we can divide u by u squared, and we can divide negative 1 by u squared. So this one is more just simplifying before we actually integrate. And then we can say this is 2 times the integral. This can simplify to 1 over u, which will integrate using ln, so we don't need to bring that up with a negative 1 exponent. We should bring this up with a negative exponent. Oh, it's not plus, it's minus. Come on. U to the negative 2 tu. So finally, when we get to a place we can integrate this, it'll be 2 times 1 over u will be the ln of the absolute value of u minus u to the negative 1 divided by negative 1 plus c. A couple things. We're going to make sure that we answer with x's because that was our original problem. And we can simplify this negative exponent in dividing by a negative 1. So this is 2 times the ln of the absolute value of x plus 1. We have to leave the absolute value because x plus 1 could be negative. This will be plus x plus 1 to the negative 1 plus c, because negative and a negative will make a positive. And if you wanted to, you could distribute that 2 and have 2 times the ln, the absolute value of x plus 1, and then plus 1 over x plus 1, that negative 1 exponent plus c. Either one of these are acceptable answers. You should know the different ways. Oops, I didn't distribute the 2. There'd be a 2 here because that 2 would go to both of these. And that could be a different form of our final answer. Our properties of ln also say we could move that 2 here, and that x plus 1 could be squared, is another way that you can see that answer. Okay. So let's look at another way we can integrate. This example, example 4, is the integral of 1 over the x ln of x dx. So let's see. This is a case where we are going to be using u substitution again, but this time we are going to be using u equal to ln of x. So this is a little bit of a different category of problems. When we do this, if we're going to put u, that is u. A lot of times it's easier to split up this problem. We can say that this is 1 over x times 1 over the ln of x, because this is x times the ln of x, and we can just write them as separate fractions. So when we do this, and we do u equals the ln of x, that means du is 1 over x dx. dx, do we have a 1 over x? We do, right here. Those two things are going to make du. So we have the integral of 1 over u du. The integral of 1 over u is the ln. ln of the absolute value of u plus c. We put our u back in, the ln of the absolute value. Our u is ln of x plus c. So when we integrate this, we get the ln of the absolute value of ln of x plus c. We have a couple more examples to do in this section, and then we're going to talk about definite integrals. You'll find those on the second video. So go ahead and finish this one up, and then you'll move on to the second video for the rest of this section.